today I want to, first of all, give you a quick intro on what preconfs are, but also I want to highlight the benefits of preconfs, because there's been a couple weeks ago, like a lot of drama and criticism and FUD, and I think a lot of it is somewhat misfounded, and so I want to kind of have an opportunity to talk about these criticisms. Okay, so part one, like what are preconfs? So first of all, I want to introduce a new terminology. Actually, I want to steal terminology from Solana. So we have the notion of a slot, that is our unit of time within consensus. And what we're going to do is we're going to zoom into the slot and look into more granular time that we call ticks. So in Solana, there's 400 millisecond slots, and each slot has 32 ticks. So that's 12.5 milliseconds per tick. There's another project called MegaETH that has 1 millisecond ticks. And then the other notion that I want to steal from Solana is that of a shred. So we have a block. What if we zoom into the block and we basically talk about like portions of the block that we call shreds that are built from top to bottom? Okay. Now, what is a preconfirmation? Very simply, it is when the user talks to the next sequencer, the next proposer, and asks them to include or execute their transaction at a specific place within that block, and for the proposer to give a promise that the user's transaction will get executed in such a way before the block is even built. So it's very, very simple. The way it works is that the user finds the next sequencer in the look ahead. I'm using the emoji 1, 2, 3, 4 for the sequencer because it's ordering transactions 1, 2, 3, 4. Sending a request, please pre-confirm my transaction. The sequencer says yes. I promise to include your transaction in position number 10, and the Uniswap price that you'll get is like $12 per token. And the user, within one ping time, within let's say a few tens of milliseconds, knows what the result of that transaction is, even before the block is produced. Now, how are pre-confirmations enforced? So in the context of Solana, the way it works is that they have this thing called a proof of history, which is like this fancy cryptographic delay function, like a VDF. And the idea is that if you commit to shreds every 12.5 milliseconds, it's very difficult to go back in time and rewrite the shred history. But another way to do commitments is to use collateral. So the pre-confer can have some collateral at stake. And if a promise was made and the pre-confirmation was reneged, so the user is kind of unhappy, then you go slash the proposer who didn't honor the pre-confirmation. And there's basically two types of faults. There's safety faults, where the sequencer promised to include a certain transaction at position number 10 with a certain Uniswap price, but instead a different transaction was included. So that if you're an honest proposer, that should never happen, and if you do it, you'll get slashed. And then there's this other type of fault, which is that the proposer missed their block. Their block got reorged. And there's some doubt as to whether or not like reorgs make pre-confirmations like brittle and not robust. And I'm actually not at all worried about the liveness faults. And the reason is that there's basically two reasons why slots get missed on chain. The reason, well, other than you just being offline for the whole slot. Reason number one is that you build on top of the wrong parent. Or reason number two is that you broadcast your block too late into the slot, and so it doesn't reach the attesters soon enough. Both of those things are within your control. Like if you have a good enough setup with a good internet connection, you'll always be able to determine what parent block to build on, and you'll always release your block on time, and it will always reach a sufficient number of the attesters for you to not get reorged. So both safety faults and liveness faults are within the control of the sequencer. Okay, so one of the big changes with pre-confirmations is the way that block building works. So instead of being monolithic, where a single entity will build the whole block at the end of the slot, for example, 12 seconds, it happens in real time, tick by tick. So the user sends the transaction request to the sequencer. That transaction just gets appended to the block prefix, and then a promise is given back to the user. One thing to notice here is in some sense that there's no mempool, right? There's like a direct connection between the user and the sequencer. The sequencer is the mempool is local to the sequencer, and the latency for the user is 1 ping time, so the amount of time it takes to communicate with the sequencer plus this tick latency, which is very small. So roughly speaking, is one ping time. Okay. Now it turns out that if you look at the way that the sequencer could operate, is that they could work with searchers that do all the heavy lifting. So you have the user sending an intent. For example, I want to buy this token. Please give me best execution. This intent is given to searchers that all compete against each other. The searchers kind of ultimately lead to a best shred that will execute the intent. That's appended to the block prefix, and then this best shred is kind of promised back to the user. Okay, so that's the end of the section of like how how I envision preconfs working, and kind of how the structure of the market changes from monolithic block building to real-time block building like Solana. Any questions on this first part?
Hello? Yeah. So we're just expecting the preconfer or the proposer to be timely, right? As in that's not enforced. This is just, they're good and we're happy that they're good. But if they can be bad, they can delay as much as they want.
Yeah. Right. So there's this problem of timeliness where basically you want to, well, there's multiple problems of timeliness. One is you want to make sure that the requests are handled immediately as opposed to being delayed, and also when a specific execution of the transaction is made, you want to make sure that the user actually receives the pre-confirmation. So that's called the fair exchange problem, where you exchange the request for promise. Now there's a whole design space around solving this. In my opinion, the most practical way to solve it in the short term is just to make the stream of requests and the stream of promises public. So every time a promise is made, just gossip it immediately. And wallets and users can just observe and police this. So for example, if MetaMasks notice that the requests take a bit longer than expected to be processed, then they can start complaining on Twitter or whatever it is. So there's the simplest way to deal with it is just with reputation, and then this policing with transparency, very similar to how relays are operated today. The other thing that you can do is try and use credible commitments. So there's SGX, for example, and enclaves more generally, where you can programmatically express a condition, which is that a transaction, a pre-confirmation request comes in encrypted and will only get decrypted after you've committed to a specific position. And so even if the operator is malicious, they can't do front running, for example, and things like that. And then there's like an even more sophisticated thing where you can use threshold encryption, and you're basically delegating the trust to a committee. But yeah, great question. I guess a second question before we go into the wholesomeness.
Hello.
Hey.
Okay. So does the kind of, how do I put this? If you want to get a transaction early into a block, so you're requesting a preconf for, say, top of block, does that open some kind of market where it becomes expensive to ask for that preconf because maybe a builder that includes that is foregoing the ability to add a preconf or a transaction later in the block?
Right. Okay. So what I've talked about so far is just the dynamics of real-time building, the mechanics of it. There is a whole economic analysis that needs to be made on the game theory and the incentives. Now, it turns out that the way that I understand at least the economics today is that a user who wants a pre-confirmation needs to submit a pre-confirmation tip to incentivize the pre-confirmation to happen. And the tip needs to match the opportunity cost of basically consuming this slot at this moment in time. And so, for example, if you're making a Uniswap transaction, you need to ask yourself, what is the MEV impact for the proposer at the end of the slot if I were to include the pre-confirmation now? And so this is where like the searchers actually come in very, very handy, because you can have like a specialized type of searchers, which you could call prices, who would try and help price these pre-confirmation tips. And one way to do it is that you have the prices give the sequencer whatever MEV they would have had if the block building was done monolithically, and they take on the price risk exposure. And then you have all the different prices that compete against each other to give the best pre-confirmation tip to the users. So it's kind of an interesting way of building blocks where you have these worker bees that help either fulfill intents or do the tip pricing.
Thank you.
Okay, so part 2, why are pre-confirmations like wholesome? I guess one reason is that they make Ethereum fast. You know, it's kind of cool. Ethereum becomes a cool kid, just like Solana, and you know, users start loving it. Great. The other reason why I think pre-confirmations are very wholesome is that they give us a credible path towards fixing Ethereum fragmentation. And I have this meme where it's the united chains of Ethereum. And I think one of the most valuable things we can do towards fixing Ethereum fragmentation is basically having all the different rollups and app chains use the same sequencer. So there's this notion of shared sequencer. Now, there's various shared sequencers at L2, like external to the L1 that are being built. But unfortunately, a lot of them have a new token or a new brand, or they kind of introduce, you know, some sort of opinionation. So for example, you could have like the Optimism superchain coming up with their own shared sequencer. And then you might have the Arbitrum guys coming up with their own sequencer. And you might have like, you know, Celestia and Espresso and Astria. And the problem is that if you don't have like maximum credible neutrality, you don't have a clear selling point for the ecosystem to adopt a specific shared sequencer. So for example, will Optimism use the Arbitrum shared sequencer? Probably not, and vice versa, probably not. Now it turns out that there's other shared sequencer, which is the L1 sequencer itself. So Ethereum layer 1, the so-called based sequencer, that could be used as a shared sequencer for the whole ecosystem. But the number one downside of the based sequencer is that it has 12-second slot times, which are very, very slow. And so if we can make the UX amazing, then we can just all use the base sequencer and kind of go back to this user experience and developer experience where I have a contract on rollup A, I can call a contract on rollup B just like they were on the same rollup. That's the notion called synchronous composability. Okay, so potentially pre-confirmations can fix Ethereum fragmentation. Another kind of reason why pre-confirmations are wholesome is that they give breathing room to the L1, right? Like the strategy that Solana has taken is like, we're going to shave every single millisecond, and eventually we're going to have 60 millisecond block times. And there's kind of this race to zero, and then the Solana validators are like, oh, I can't breathe anymore. I need like 100 gigabit connection like within this data center, and like I'm very constrained into what I can do. But if pre-confirmations kind of give us the UX benefits of short slot times, then now there's a bit of room for Ethereum slots to be like a little bit bigger, and basically instead of all racing to zero and racing towards centralization, preconfs can give space for the L1 to be much more decentralized. Another really interesting consequence of pre-confirmations is that it changes the MEV pipeline. So we're all familiar with this pipeline. We have the user, sends their intent or transaction to the wallet. That goes to some searchers, to builders, and ultimately the proposer, or the sequencer in this case. And one of the things we've observed is that there's intermediation between the users on the left and the sequencers on the right. And these middlemen have become very influential. So one of the things that they can do, for example, is censorship, right? It's like, it's capitalism, whereby like the most economically dominant actor can enforce their preferences on the ecosystem. So one example here is beaver build. Like, they are the strongest animal in the forest, and if they want to censor, which they do want to censor, then now, you know, tough luck. That's what Ethereum gets, censored blocks. But on the other hand, with pre-confirmations, it's a completely different dynamic. The user has a direct connection to the sequencer, and then the worker bees are kind of, you know, just worker bees. They're not the gorillas of the forest. And they're kind of servicemen. And so one of the really cool things is that you actually have much, much less censorship, like an order of magnitude less censorship. And the reason is that with monolithic block building, there's two entities that can censor. It's either the sequencer, right? The sequencer has monopoly power over the slot, so they can do whatever they want, but also the top builder can censor. In the context of continuous block building, only the sequencer can censor. And now we have statistics in terms of proposers that are connected to non-censoring relays. So about 90% of validators are not censoring. Only 10% of like super ultra regulated validate and operators are connecting to only the censoring relays. On the other hand, almost all of the censorship comes from the builders, right? Because 2 of the top 3 builders are censoring, and that accounts for about 2/3. So we have an opportunity here to reduce censorship from 66% roughly to 10%. So that's like a 6x improvement in terms of censorship with this real-time block building idea. And then another kind of interesting thing, which I want to think more about, is that we now have this order flow canonical place, kind of shelling point to send it to. So when Ethereum was created at Genesis, there was this natural place called the public mempool where everyone would send their transactions to. And what we're seeing is that the public mempool is dying, and it's dying at an extremely fast pace. So roughly 30% today of transactions are not going through the public mempool. They're going through centralized encrypted mempools. So there's Flashbot Protect, there's MEV Blocker, there's a MetaMask, who a few weeks ago came up with their own public mempool, and encrypted mempool. And encrypted mempools are good in some sense because they prevent the front running of users and the exploitation of them. But what's happening as well, interestingly, is that the wallets have a huge incentive to integrate with these encrypted mempools, and the reason is that they can capture the backrun. So every time you use Rabby Wallet, for example, or you use MetaMask, and you make a trade and it moves the price and there's kind of a backrun opportunity, the wallet captures that. And you might not notice it, but it's like millions of dollars per month of revenue for these wallets. And so what we have now, instead of like one public mempool where everything is sent to, we have like 10 different encrypted mempools, and we have a public mempool which is dying. And my prediction is that within 12 months, 90% of transactions will go through these encrypted mempools, and only 10% will be left for the public mempool. But here, with pre-confirmations, if as a wallet I want to provide a pre-confirmation like service, I have to go to this one entity. Like, that is the canonical mempool. I can't do anything else. If I don't do that, I just can't provide the pre-confirmation. And okay, final slide. Pre-confirmations are wholesome because they can happen very, very, very soon. And we have this rapid response team in some sense from the wider community. We have like 100 people, roughly speaking, that are like working on pre-confirmations now. And we had just a few weeks ago, a DevNet at Zuberlin. Now we have this testnet with like a proof of concept with an integration with MetaMask So we're making huge strides, and like my prediction is that by this year we will have pre-confirmations on mainnet, so that users can start getting familiar with the fast UX. Okay, happy to take questions if I have time. Thank you. Mike is coming.
So you showed that sequence in the change of the MEV supply chain?
Yeah.
So if you go, so if the user gets directly the pre-confirmation from the sequencer, but the searcher or pricer actually defines the price, how is it possible to get like a pre-confirmation without knowing the price of the transaction?
Right. So just like today, you know, whenever you perform an action, you provide like a maximum tip that you're willing to pay, or if you're making a trade, you'd say like maximum slippage or something. So that provides like safety bounds, like guardrails for the user. But really what you want as a user is just best execution, like whatever's available by the market, you want the best thing. And so really what you want is a very healthy competition among the searchers to be competing against each other to give you the best price. So yeah, if like, unless you're like literally collocated with the sequencer, like there's going to be some sort of time lag between the state of the world and what you observe, and so it's very difficult for you to know a priori kind of what execution you will get. But I think the important thing is that you get the best that the market has to offer. If you really, truly care about like a very specific outcome, then you can encode that in your intent. You could say, okay, my intent is that I get exactly this price, for example. That would be a limit order. And there's two outcomes. Either it gets fulfilled or it doesn't get fulfilled, and then you'll know immediately which of the two possibilities happened.
So you mentioned that, thanks for the talk. You mentioned that there are these censorship benefits that
Yes.
Before we had both sequencer could censor and also builder could censor, now only sequencer. In this model, this makes sense to me, but at the same time, this sequencer role now has to be this very powerful entity, right? That's able to hold lots of connections and do things very fast. So they're not called a builder, but they remind me of the builder and role. So maybe could you comment on this? When taken that way, have we really increased the ability to reduce censorship or not?
Yeah, okay, great question. And first of all, I want to kind of give a little bit more flavor on the censorship opportunities today. So if, for example, MetaMask were compelled by the US government, because they're a US company, to censor, and they only send their flow to censoring builders, then now basically every single block would, you know, almost all blocks would be censored. So it's not just a problem with the builders, but like, for example, if Jared from Subway would only, you know, send their flow to builders. So actually it's all like these power dynamics in the whole pipeline that jeopardize the state of things. It just so happens that today, like the builders are like most clearly the pain point. Now, your question is, in order to provide pre-confirmations, you need to be sophisticated. And so there's maybe like only a handful of entities that can provide this. And like, what if there's a bad outcome there? So the way that I think about it is that we can introduce this notion of a gateway, which is the same as a relay, but for pre-confirmation specifically. And the proposers can delegate their sequencing rights to the relays. And so if the proposer has a specific preference, for example, it's a non-censoring gateway, well, they can express that just like they can express their preference by connecting to a relay. But they themselves don't need to be sophisticated. Now, one of the important things is that whenever you delegate power to someone, you want that entity to be held accountable, and you want it to be like fairly low barrier to entry for someone within the ecosystem to provide that kind of service. And the very nice thing with gateways is that they're similar to relays in the sense that essentially the only skill that you need is DevOps. And DevOps is like a fairly commoditized thing, as opposed to a builder where you need capital, you need connections, you need an army of PhDs, and you need fancy algorithms and whatnot. So I think it will be a good outcome because the barrier to entry will be fairly low, and these entities will be held accountable.
Thank you. Are there any concerns with pre-confirmation provider spam? Because pre-confirmations for swaps are essentially derivatives, and I could see there being a lot of potential for sophisticated actors to hit them with toxic flow constantly trying to get filled.
Right, great question. So the way that I think about it is that pre-confirmations are for unsophisticated users. And the reason is that as a user, I'm going to have to pay fair price. By fair price, I mean the expected MEV impact on the proposer plus epsilon. And the reason is that the sequencer needs to have an incentive to participate in this game, so they're going to charge a fee on top of the fair price. On the other hand, sophisticated actors, they're only interested in execution of fair price minus epsilon. And so they're never going to meet, right? Like the proposer is selling fair price plus epsilon. The arbitrageurs, the sophisticated actors, are only willing to pay fair price minus epsilon, and it's never going to meet. And so really pre-confirmations are only for users that are willing to pay a premium for the UX benefits of pre-confirmations. It's not a tool really for the sophisticated arbitrageurs.
But doesn't this turn into a latency game to some respect? Because you could see the pre-confirmation provider having like stale bids open, right? And then the sophisticated actor tries to pick them off before they can update them.
Yeah, so this is where the worker bees become helpful. So basically, some subset of the searchers can be prices. They take on the price risk, not the proposer, and they will have like ultra low latency like connections to all the exchanges. And if they have stale prices, it's their problem. Like they're taking on the risk, not the proposer.
Okay, makes sense. Thanks.
Hey, thanks for the talk. How can I trust the searcher to give the best X? In particular, if you talk about high frequency connection to the exchanges, that's a big barrier to entry to me. And will the user always pay max slippage regardless of that?
So the reason is competition. So what you'd expect would happen is that the price that the user pays is going to be the second best price. So it's just like standard like auction dynamics. So let's say that max slippage has like $100 of MEV to extract. Well, one of the searchers is going to say, okay, I'm willing to give one ETH of $1 of rebate, and I'll only take 99. And then the next one will say, I'll take 98, and then eventually it goes down to like the winning searcher just takes 1 cent, and like 99.99 cents, $99.99 goes to the user. So basically, the amount of MEV that the user doesn't get is basically a reflection of how uncompetitive or immature the competition at the solver level is. And so this is why it's very important that the auction that is being run by the sequencer or the gateway, however you want to call it, is credibly fair and neutral. And there's like various ideas, for example, to use TEs like Suave and whatnot, where every searcher can feel comfortable opting in. They know that they're not leaking alpha or anything like that. They know that everyone's being treated fairly, and then users get best execution. Not working, but basically I'm out of time. Thank you.